Good afternoon, everybody. Thanks for joining us for the Dynamic Solar Shading and Sustainable Buildings webinar today. Before we get started, we'll just take you through a little bit of housekeeping. So as you know, you'll see that you're actually able to listen in today, but you're all in a muted mode, so you're not able to speak with us. However, if you do have any questions, we encourage you to write it in the window pane, which is just on your right underneath the questions tab. And we'll take questions throughout the whole webinar. And then what we'll do just towards the end, we'll have about 15 minutes where we'll be reading out those questions and going through them with Anders. And if we don't get to your questions, what we'll do is we will publish a document after the webinar, which will outline all of the answers. So I'd like to introduce Anders Hall, who is the International Affairs Manager with Somfy International. So working in the Home and Building Organisation at Somfy and as a team member of the Building Control Business Group, Anders' mission is to support the local Somfy business units globally in promoting energy efficient solutions for the commercial sector based on dynamic solar shading. Anders is globally active, speaking in relevant seminars, events, or in contact with local legislators as he represents both Somfy and the industry as a member of the European Solar Shading Organisation. Anders works to share his vast knowledge and experience enhancing the understanding and importance of dynamic solar shading as a HVAC solution, providing energy efficiency and creating a healthy indoor climate for the benefit of both society and people. So thank you so much for joining us today, Anders. So what I'm going to do now is just pass on to you. So just...
Okay, good to go. Hello and welcome everybody. Thank you for making the active choice to joining us during this webinar. As part of my preparations when I was sitting home in Sweden preparing for this webinar, I'm quite a frequent listener to TED Talks, and I came across Al Gore and let's say a updated version of his speech on what's going on with the climate change, and one thing stuck with me that I would like to share with you as part of the introduction. And he said that during 1 hour, which is equal to the hour we now spend together, the sun will radiate the equivalent amount of energy on the globe that we globally consume, all of us, during 1 year, which is quite a huge number. And I came also across this slide on the internet where this solarist said that the yellow part of that hot part of Australia, the solar radiation on that area would be also equivalent to the global energy need. Quite significant. In January, I had the opportunity to have a meeting with a green consultant in New Delhi, and he told me something else of interest. He said that 1 square meter of a facade exposed to solar energy during 1 year gave the equivalent amount of energy needed to make about 40,000 cups of coffee or boiling 30,000 eggs. And for me, working with solar shading, that was quite an interesting comparison, because that square meter could very easily be a window. So I say, I still meet people saying, do we really need solar shading? And I would say, let's take a closer look. So, dynamic solar shading in sustainable buildings. We start with a short introduction, and I would like to share with you, let's say, some general points that and information I've been gathering over the later years, working predominantly in Europe, but also more and more on an international basis. And I have some information also that we share from the European Solar Shading Association in forums like this. But to kickstart the thinking here is that with this slide I try to visualize the let's say, kind of, maybe not confusion, but uncertainties that we all face together in the building industry, whatever role we're in, if we're working as architects, green consultants, suppliers, M&Es, whatever, because we have all these new demands coming up, being developed. We have rating systems. We have a need for really seriously making our buildings energy sustainable for the future. And let's say that the road to that future is not entirely clear. The world is full of good intentions, but the working models still needs a lot of modernization for us to be successful. That's a personal conclusion I often make. But with this presentation, I hope at least to bring some kind of inspiration, a few ideas that could help you all in getting there. From European solar shading side, when I travel around, I hear often people relate to Europe like, well, in Europe you're so developed and you're so modern, etc. And I said, well, for some parts that's true, but for some parts it's definitely not. And we do the same in Europe, what I see all over the world. We put a lot of good green high-level intentions into development of new buildings, but in Europe the new building stock only accounts for about 1 to 1.5%. So lately now the EU Commission, for example, have recognized that we seriously also need to start addressing the existing building stock if we should ever have a chance to become as sustainable as we need in the near future. We see different plans for reaching out for 2020, 2050, etc. And as an organization, we work also with other organizations. Glass industry is one, and through them we learned that about 86% of all windows in EU, the EU 28 countries today, in the existing building stocks are actually single or double clear glass. So here is a huge potential to do retrofit things and really speed up the sustainability of Europe. It's really a big, big issue for us in Europe as well. I learned that Australia is the same. It's a lot of single or maybe double clear glass. I see it in the US. So we all share this globally. See the same thing everywhere. Light, quality of light is important. I think that most of you are familiar with the picture I show you at the moment, with the different wavelengths we receive from the sun, and obviously the visible part is the key part, and the UV and the IR is the one we would like to manage somehow as much as possible, because for buildings it's the potential heat. But we must remember through the presentation now, it's for those of you that might not know, the visible part still accounts for potentially about 43 to 45% of the energy that we could be having coming into our buildings. That's a bit of a challenge. If we look at the quality of the daylight we receive, and then we add, in this example, the quality or the wavelengths of the fluorescent light, or like we now go more and more for LED, because we obviously find it interesting. It consumes much less energy. This comes from a colleague of mine in Esso in Austria, who's a professor on this topic, and he tells me that it's quite interesting, because it's a bit like with the mobile phones, to put it a bit strong, that when we got the phones, we didn't know whether everybody would get brain cancer in the next 5 years or something, because we didn't have anything to compare with. It's a little bit like this with the LED, because yes, it's low energy, and yes, it brings light, but we know still quite little about what it makes, what it brings to our bodies as human genetic beings. I heard recently they just released some research in UK in January. I couldn't attend, unfortunately, where they've done some early studies on the subject. So I think we'll find out more over time. Then we have the biological clock. People not necessarily know about this, but every day we experience jet lag because our biological clock doesn't run on 24 hours just because we invented a clock. It runs 1 hour off every day. So for the third receptor in our eye, we really need to be exposed to natural daylight of the full spectrum to help the body balance between the cortisol and melatonin, making us sleepy, or cortisol to make us wake up and be more active. So quality of daylight is extremely important for us as human beings, particularly now, today in modern life, where we spend so much time indoors, in cars, in office, in our homes, and very little time. I mean, I assume you have the same thing in Australia like we have in Europe, that children in schools, for example, spend much less time, active time outdoors, and it's becoming a problem for us as human beings. Being members of Australia Greenville Council, I'm totally convinced you're well aware about these summaries and studies and papers coming from the World Greenville Council, so I won't go through them. You probably already saw them, but I'd like to share with you that I'm very pleased to refer to those during my different seminars, and I do market your message every chance I get. We are also defining that in our own industry, but also, let's say, the receivers or the users of the products from our industry, the knowledge around what dynamic solar shading can bring and the potential of it is, the knowledge of that is normally quite low. So we've been working on developing a training program. I'm chairing that initiative, and I'm running these trainings now in, let's say, version number 1 to test it out and evaluate, and hopefully by the later part of this year we will start launching the first e-learning programs from Europe that will also be made available for people in Australia, obviously, using the modern techniques that we have available today. In ESO, if you're interested more in detail, the left here is high performance dynamic shading. Is quite substantial study we commissioned from ESO, Professor Hutchins in London. They collected a huge amount of studies around Europe. We divided Europe into climate zones, and it's about 130 pages, telling a lot and summarizing about the potential energy savings in different climate zones using dynamic solar shading. It's also summarizing what a lot of these summaries conclude in. Yes, it's about Europe, but I mean, the basics of that study to a large extent is very much applicable to Australia as well. You just need to adjust the numbers accordingly to the climate conditions. We also issued a new vision on solar shading, which is like our version of a political position paper that we provide to the EU Commission, and we're obviously happy to share that, and it can be used also in this sense in Australia. They are fully free downloadable at the ESO website if you're interested. We move on and we look at again the knowledge sharing. In 2008 we came into contact with the let's say the Europe version of ASHRAE, which is the HVAC organization for Europe, called REVA, and they issue guidebooks for their members, about 120,000 members in Europe, on different new developments and topics of interest. And they totally agreed that these people need a guidebook on dynamic solar shading, and that's the book you see to the left. Unfortunately, the only way to come across it is to go to the REVA website and order one online, but it's they don't agree to create PDFs and share it because they sell it. But I can recommend it. It's totally endorsed in terms of content by the board, technical board of this organization. So it's purely non-commercial, factual information that could be good basic knowledge for those of you working as M&Es or sustainability consultants. Then we have a 12-page brochure we created explaining more on the ISO standards and EN norms that describe how the contributions of our solutions should be treated or should be calculated in order to do it in a fair and comparative way. So if you're interested and you're into deeper levels of building simulations, I thoroughly recommend you to download this one and use it as a guide, for example. Another very important thing, also driven by the EU Commission at the moment, is that the building sector is full of, let's say, marketing-related information on what different products can, how they perform and what they can bring in the green aspects of buildings. They say that a little bit like enough is enough, and through a program called Quality Check, they are now pushing the building industry, all suppliers, manufacturers, to really gather their information in validated databases that should be, in terms of quality, thoroughly checked and endorsed by trading organizations. So we are told by the Commission that we are in the forefront as a solar shading organization, and we actually have a pre-launch of what you see on the screen right now. It's not fully functional. All information is not implemented, but again, by the later part of this year, you will be able, free of charge, to access here and find information from all the major manufacturers of solar shading material, slat materials or fabric materials around the world. So a very positive development. And this also connects to the last one. We will come back to this last one at the end of my presentation. It's connected to what is called early stage building optimization, the first simulation tool created where the, let's say, a proper organization like ESO have been given the opportunity to give input and pay influence on how a building simulation tool is created and how it really calculates and treats our products properly. I'm sure there are other alternatives out there that would do the equivalent, but in this case we know, because we have been part of it, to secure the quality. And the tool you see on the screen is free online, but as I said, I will come back to that. A bit more general, my own perception is very often that solar shading is used as a band-aid. Something goes crazy and we use it to solve a problem in retrospective. And it's very often considered as an accessory to a building, but I would argue it should be considered for the future sustainable buildings as more or less a necessity. A huge difference. Just to touch base on the private building sector to show you a tendency we see in Northern Europe. And that is, I mean, we go for net zero energy buildings now as much as we can, even plus energy buildings. And obviously insulation in our climate is extremely important, but we still have significant heat loads from the sun. So in, you could say, kind of a desperation, the windows are shrinking and in some facades even disappearing because the sun creates such problems. And buildings like this in Scandinavia are maybe built for 2 grown-ups and 2 children, but and the indoor temperature is totally balanced by some kind of mechanical system. But I say, what about when I have 10 relatives coming for Christmas and the heat load goes through the roof? The house becomes like a sauna. I mean, I don't see this as a particularly positive development. By using solar shading, we can maintain the window sizes instead. And I will come back to this, how we can make them dynamic. I see another tendency. I mean, I know, for example, that in South Korea, the building authorities, they are actually considering now for the near future, maybe even next year, to only allow a window-wall ratio of 40% glazing in a facade to get the building permit. and that would set us back quite significantly in time. I mean, in Scandinavia, back to like the 60s or 70s. Not enabling these people to have larger windows for the livability of the building, the quality of life that we would like to have. So again, very much depending on that the sun actually do present quite a bit of problem if we don't manage it properly. A concrete example that I find very positive is this building, the Shard in London. You might have heard of it as architects. You might have heard about Renzo Piano, which is a very famous architect. And I found this article in Sunday Times during the development of this building when they said, we are aiming for a G total value on the facade of 0.12. I come back to the G value for those who are not familiar with this value, but it means when the facade is active shading, it allows for about 12% of the outdoor energy to enter the building. And another comment was that the key thing is the intelligent system driving the blinds, because without that the building wouldn't work. Quite a strong statement, because you can imagine the kind of size of investment being done here in a building like this. Then we have organization like International Energy Agency, where we have a very good relationship with today via ESSO. And they have also gained knowledge about the potential of solar shading and during the past years. So in their roadmap from 2013, these are two snapshots and quotes from texts that they fully support the use of solar shading and dynamic control in both new and existing buildings. And this is a document, obviously you Google it and you will find it, and it's free to download and read for those of you having interest. Coming back to this HVAC organization in Europe again, REVA, from the introduction in the book, Professor Olli Seppänen, this was back in actually 2006, I met him the first time, and he said this, that solar shading is actually not only solar shading, it is an active part of the total HVAC solution of a building and should be treated as such. A very, very strong and clear statement from a very knowledgeable person. Next chapter, I would like just to share 4 slides on key things about the combination of glass and shading. And hopefully here, I would say this is one of the most important parts of my presentation. So I hope I've made it possible for you to stay interested and awake now. So G total. I'm still surprised the amount of people I meet, how few actually know what this means. If you don't, I fully recommend you to find out before you go home from work today. U value, the measure of insulation properties, is widely known normally, but the G value is extremely important. And it's about the amount of energy entering our building, predominantly through the glass, obviously. So I would like to say that when you have this hole in the wall here and you start thinking, which means very early in a project, instead of starting by putting a lot of effort on the glass specification, start making the consideration, do we want to use solar shading, yes or no? If no, obviously you continue, but if you say yes, then you go further and say, would we have it on the inside or on the outside, or if it's a double skin, interpane, and then that will guide you to what kind of glass specification you should be looking for to be able to harvest the best benefits possible from this combination. So this is a very strong recommendation I give you just to for you to consider. And I will show it in a more concrete way. What I did here was I went on the Saint-Gobain website at home in Sweden, and I picked out a couple of glass specifications in terms, and I looked at the values in terms of the red one, which is the G value of that glass, and the blue one is the light transmittance. And I start to the left with single clear, then double clear, and then a number of different heavier and more selective coatings going to the right. And what we see here is more or less a linear kind of structure. We see the far left, single clear glass, non-coated, one extreme. The other extreme is to the right, where the G value touches around 20% of energy. But we also see that the light transmittance follow, more or less. In the middle there, the glass industry is doing a fantastic job. They are maintaining the light transmittance fairly good, bringing down the G value. But the level of G value there is rarely what modern buildings in a lot of our climates require. It's more to the far right. And that also means we will lose a lot of light at the same time, or daylight. So I would argue then that if you introduce in this picture some kind of dynamic solar shading, and you stay with the glass spec to the more left of the slide, you could allow this kind of level for both G and light transmittance, but when you need it, you can bring it down to here, which is like around 10%. And you remember the shard they were targeting about 12%. So it's about half what many of the modern glazings can even achieve today. And this is what I call the dynamic G value. It's dynamic. It can be flexible, follow the seasons, follow the need of the building, can be adapted to the need of the people in the building instead of a static solution 24/7, 365 days per year. So, a few general slides on this thing about dynamic shading, and I would like to focus on one particular part, which is manual or not. Obviously, manual is widely used. It's the cheapest solution, most simple one for the builder and developers, but it leaves the tenants with the problems. This is actually, could be a building more or less anywhere in the world. It could have been for me in New Delhi, it could be Seoul, Shanghai, I see it in Sydney. It just happens to be in my hometown in Gothenburg a couple of years ago in March. A sunny day, cold weather, you see the trees are without leaves, and it looks kind of terrible as well. But there is a misperception about manual shades. And I'm happy to share with you that I knew this from my more or less 20-25 in the industry, working as a project sales guy and a sales manager, but I didn't have any proper, let's say, proofs to support my opinion. But through an EU project a couple of years ago, I come across this institute, Estia, in Switzerland. They are totally financed at this point by the Swiss government, because the government there are looking to upgrade the building regulations on retrofit for light solutions, light fittings, etc. And it so happens it ended up including also the use of solar shading. So to give you some background, they chose a campus where they had external Venetian blinds, manually driven, because they are visually more easy to analyze the movements of when they're outside. They were mounting webcams and photographing these facades in east, south, and west directions every hour during daylight hours for a full year. So they had 500,000 pictures that the students analyzed in terms of, did people change the angle of the slats, or did they pull the blinds up or down, or move them in different positions? And without going into details, you look at the bottom red figure here, the weighted average movement of any kind over the year was 1.7 times per week, which means it's not moved a lot at all. Light is not my topic today, but I still would like to share this slide with you. The conclusion on the light they made was not the 500 lux on the table we're all more or less used to from the past. It was less than half level before people actively switched on the light. And the conclusion is based on the use of LED screens today, to a higher extent, and much less working with pen and paper, reading books, etc. But it's less than half than the standard for light today. And there is a connection again in their summary to the importance and the potential of the automation of solar shading and significant savings potential. So this is again a study I'm more than happy to share with you, and we make sure to organize a proper way to distribute that to you if you just let us know you're interested. Before we go on, another aspect of solar shading, also a very practical but very important one I'd like to quickly show you, is about the color of fabrics. Here you see to the left a patchwork designed by an architect, but what I did with that building to the left, I walked through the entrance and I look at the two windows to the left, the white one and the very dark one, and I use my mobile phone and I just take a picture. And already here we see a significant difference in let's say, visual quality through that fabric. And if I move 2 meters back and take the same picture, the white fabric starts to glow, and it actually becomes worse than the natural sun. So for you, those of you listening, being architects, I just would like to highlight the importance to consider the colors. I know white, or more or less white, is very popular because it's neutral, but it does have this side effect that I would like you to be aware of. The other one, the small Belgium office here, whether you pull down in the upper left corner a very dark fabric, looks very shut down and closed, but on the big picture you still see the visual contact with the outside through the fabric, and it's a bit dimmed, but still very good. Also important to know and understand when you make choices of fabrics. Controls. How do we control this? Well, a good friend of mine, Steve Selkovich, professor at Lawrence Berkeley in San Francisco, gave me a good quote a couple of years ago. So to manage the energy from the sun is like trying to drink from a fire hydrant. The key is control. There are various factors. I mean, how will the building be used? Should we drive the blinds per window, per facade, per floor? How is it used? How the tenants moving in, etc. What are the functions? The sun will move around, cast shadows on the facades, etc. We also have a summer situation. We have a winter situation. How we can utilize the blinds to get a better U value on the facade during the cold period, for example, is not widely known in the market. About light distribution, if we control the blinds, we can also give light balancing functions in the building a fair chance to follow and compensate for the daylight, but also for the common light distribution for the benefits of people working there in the working environment. Weather, obviously, constantly changing. We see it here in Sydney now. We've had heavy rain this morning, cloudy now. We are getting more towards clear sky and sunny. And then there is a choice of some kind of control system, where obviously companies like ourselves or likewise would be ever so happy to support you in any way we can. Here I prepared a movie. I'm sorry I'm clicking past it because I was told this morning that movies won't work in webinars, so we have to skip that demonstration and skip to a best practice case, some short slides on a very good example how we can make all this work. It's from 2009 in Gothenburg. I was personally involved in it at the time, and here they made a choice of outside Venetian blinds, motorized and automated, about 270 of them on all 4 facades around. For those of you interested in figures, we had 60% of glass and a weighted U-value average of 0.4, which is quite low, particularly at this time, 2009. But the interesting thing is that the planners and the tenants of this building were, or is, an HVAC consultancy firm, an M&E company. So they measured this building live after they moved in, and they still measure it today. And in 2012, they, after tweaking the systems in the building, after a couple of years, they reached a building energy level of about 40 kilowatt hours per square meter year, which is significantly lower than many other buildings around that I come across. Here you can see how they did the pre-calculation on the cooling. This was quite some years ago. Today they know a lot more. They're actually, this company is actually the #1 specifier of dynamic solar shading in Sweden at the moment today. But without and with solar shading, the cooling energy estimation, but the result was significantly lower, and it came from mainly 2 things. Less people in the building, they're consultants, they visit customers. So less thermal internal loads, but also positive expected extra from the shading, about 30%. And I asked these, the men I got to know during this period, I asked them, well, how could you summarize the generic success factors? How come you became so successful when so many others fail? And they said, well, we used a holistic approach. So all the major stakeholders were gathered around the table at the very, very early stage. Low-tech technology, off-the-shelf standard, no going to the moon technology being developed or tested for the next 5 years, standardized. Proper information to all people moving in so they would understand and could interact or accept, have a higher acceptance of why the building would behave in certain ways, and also teach them how they can interact with that. Presence and absence was key, and again, shading was more effective than expected. So key success factors, I summarize this at cooperation is working together, not working at the same time. Very important. It's a combination of things, and I put KNX here in the middle. It's just one example to highlight that technology today provides us with the opportunity to work together, share information over system boundaries, etc. So that the possibilities are there. It's how we use them and utilize them that will bring the success or not. From a university in Denmark, they made a study for SO on this a couple of years ago, and they say to get down to the levels we need for the future, it's all fine with components, we can create systems, but it's the conceptual level that will bring us to the success we need to reach. Cost and return on investment, I will pass that one very quickly, sorry, and just highlight the fact that when you do an ROI calculation, make sure not only to look only at the OPEX cost, the operative expenses. You have to consider the capital investment as well, because there are significant savings to be made on glass, for example, right-sizing the initial HVAC equipment. That could pay for a lot of solar shading. So an ROI can be very positive if you make it the right way. Now, last chapter about this simulation tool. I'm quite sure that most of you are familiar with at least 1 or 2 or 3 of the logotypes I show you on the screen. Maybe some of you have heard about Equa, the yellow arrow up on the right. This is the company I've been working with for 2.5 years to develop this ESPO simulation tool. And another movie we unfortunately cannot show, but the ESPO Lite, the left blue version, is a free online and free to install software that you are all welcome to download, and I'm sure we can provide you with the download link via email so you don't have to make a note now. And I welcome you to use it. And I can only say everything is done totally according to ISO standards and EN norms in terms of calculation. And ESSO as an organization has totally endorsed how this simulation tool is shaped and developed. So you can, for starters, use it as a benchmark, initial benchmark, when you make these initial choices. And just to show you a quick example, this is the starting screen, and we zoom into the window part here, where you with a few clicks can make the choice of shading, what kind of fabric and what kind of glazing, and you click the green button on G for system, and you calculate according to the ISO 15099, and in a few seconds you will have this result, with and without shading, and the key values. So this is coming back to helping you making the right choices of the combination of glass and shading that I mentioned earlier. A free tool for everyone to use. You can go deeper still in the free version, and this is where I'm a solar shading guy, so I wouldn't know anything in detail about these M&E or HVAC specialties, but they are present, surprisingly advanced. Obviously, also, you're welcome to use that. And if doing so, it's very important that you have the right climate data. And here you see what climate data from ASHRAE fundamentals in Australia only that is being implemented. So we've got the global data from ASHRAE implemented in this tool as well. So wrapping up the last few minutes, by this presentation I hoped I gave you some inspiration and some things to consider. I would recommend you, if you're interested to follow what we do in the ESSO organization, I welcome you to sign up for our newsletter. We send out only about 3 or 4 per year. They are fully non-commercial, based on facts. We do studies and different kinds of activities, development of database, for example, etc. The REVA guidebook again, but you look for the REVA website and you will find it in their library if you're interested. And obviously, I have quite a vast library of documents collected that I share with my colleagues here in Australia. So just again, let us know and we can prepare and submit information and documents to you digitally. No problem. We're more than pleased to do so. So hopefully some inspiration and added knowledge to oh, sorry. As a final comment, sometimes I say if I tell you something, you probably forget. If I teach you something, you might remember what I said. But if I manage to inspire you, there might be some change in your behavior next week and in the future, and that's what I'm hoping for, that we've achieved here today. Sky is the limit, you say sometimes, but not for climate change. So I've made quite an extensive traveling coming here to Australia. So just to let you know that I totally CO2 compensate for all my global traveling, at least trying to do my best to be responsible in my profession. So I thank you for the attention, and I give the word back to our chairman.
Thanks very much, Anders. So now we've got some time for questions. So we've got our first question here, Anders, and it says, Gothenburg, low tech. Please elaborate. Clients would say manual is low tech and operable equals high tech.
I hear you twice. You said manual is high tech. Yeah. Yes, I would say that. Definitely. That manual is low tech, and dynamic, motorized, and automated would be well, high tech, or let's say the technical level it's supposed to be.
Cool. And we've got another question here, and it says, is there any more data available on the ROI of dynamic shading compared with static or manual shading?
I would say we are struggling in the solar shading industry because we do know our products very well and the ins and outs of it and the costing factors. But we have a struggle with is to really project by project dig deeper into the actual cost of things like glass and HVAC equipment. So I would actually use this opportunity and welcome if anybody would like to work with us locally in Australia on that. Because we need to be a group of people doing that together. And maybe the result could be some kind of guidelines or a template that could give an ABC example that could be used for under local circumstances and bring some more clarity. So it's not a full answer to your question, but I'm honest. I mean, we are not the only stakeholders in an ROI. We need to be a group of people creating it together. So please invite us, and we will be more than willing and happy to help.
Great, thanks, Anders. Would you say that external shading is more effective than internal shading, or are both recommended?
Well, I could say a bit of both here. Both are recommended because it's definitely more recommendable than no shading at all. In terms of pure building physics and shading functionality, the external one is obviously closer to the sun and more efficient, but there are also practical limitations to that. I mean, I'm looking out the window right now in Sydney and I see a lot of high-rise buildings. And there is a practical problem mounting exterior shading on normally above 5th or 6th floor because of maintenance cost and practical things. So very often then shading ends up on the inside for those reasons. But again, with the right combination of glass with interior shading, you can still achieve a lot. But it all comes down to the quality of glass.
Thanks, Anders. We've got some more questions coming in. So you showed a slide showing various glazing combinations with internal and external shading scenarios. Have you got a preference to motorized shades or Venetians, etc.?
Well, I would say again, I'm kind of neutral there. If I understand the question correct, I would recommend roller shades or Venetians. It could be an open question of preference. Again, a Venetian blind is more effective to really cut off the solar radiation. But at the same time, during the periods, Venetian blind needs to be very closed. It also shuts off the visual contact with the outside for the people in the building. A screen fabric would allow more visual contact, but you could still have a bit of glare problems if you have a direct sun shining through the window. So I think it needs to be discussed and project by project and based on preference with the people that will be the users of it in general.
Thanks, Anders. And another question, which software package would you use to model dynamic solar shades? And is there an optimized methodology or parameters to model them?
Today, the timing of this question is quite good because the solar shading industry, I have a tendency to say we've been asleep for a long time and we woke up quite recently compared to glass and lighting industry in terms of how to control and how to communicate around our benefits. But with the technology today, we as a company, the company that employs me, we've developed a lot recently and also developed the algorithm based on the vast experience we have. But we are not the only ones. And the good thing is also that these control systems are less and less proprietary systems. We have door openers where we can communicate with HVAC systems, light systems, etc., bringing the dynamic of the building even further. So let's say there is not only one package here, there are several. and they can be adopted according to the needs and requirements of functions, project by project, to a large extent.
Great, thanks, Anders. In Australia, it's been very challenging to convince clients to use dynamic solar shading. They appear to shy away from maintenance and warranty issues. Also, they are lacking good examples they touch and see and still get a good look. So they like that glassy look. So unfortunately, some case studies are seen as sort of a Rolls-Royce case study, and they're quite expensive. Have you got any insights into change clients' views around this?
Well, I think there are a couple of things here that are very basic, and again, it comes down to blaming our own industry a bit, the way I see it, because I just said we've been asleep for a long time. When I joined the industry in the early 90s, I mean, I was still one of these people. I saw solar shading as some tip on a building, but by 95 I started realizing connection with energy. I think it comes down to knowledge and how we prioritize solar shading. Like I said in my presentation, we see solar shading as an accessory, not a necessity. But that, I think, is very often based on pure knowledge and how we prioritize the budget. Because the ROIs we've been doing with the HVAC organization in Europe, I mean, REBA would say that an ROI on dynamic solar shading is more or less, in Europe, less than 12 months in most cases. But we don't have the priorities, we don't have the knowledge, and therefore we don't know how to relate to it. And this is also when the building industry goes for, they don't have a proper budget for it, so they go for something cheap. And when they buy something cheap, they get a cheap benefit or a low level of benefit. And then the perception from the customer is that, well, this wasn't so nice, or it was noisy, or it doesn't work properly. Well, it's because it wasn't properly budgeted, it wasn't properly planned, etc. So this is why I work so hard on trying to spread the proper knowledge and awareness amongst architects and M&Es around the world, every given opportunity I get.
Thanks, Anders. We've still got some more flowing in. So, Anders, do you connect the solar shading system you sell, connect to any building BMSs? High temperature zones could be actively managed via the external blinds, or do you just use rooftop sensors to control the blinds?
Today we actually do both. So we use different kinds of sensors that are the basic sensors for driving the solar shading, but we can share information with the BMS system, etc. So, for example, you have a Saturday during winter in a cold climate, no people in the building. Normally the solar shading would go down, but then the BMS or the HVAC system can say, hey, I need to heat the building now, and could then override the shading and say, pull the shades up and allow the sun to shine in and help with free heating, putting less energy consumption on the heating system, for example. This is just one example. There are several others. So we do interact with other systems to a large extent today.
Great, thank you. And is there a significant portion of energy consumed by the operations of dynamic motorized shading?
Listening to your question, I assume you mean if we have motors in our shades, if there is a significant energy consumption from the motors. If that's the case, I can give you an example from a life cycle cost analysis that I did myself about a year ago in Sweden for about 100 blinds. And the estimated number of movements, the running time of the motors was equal more or less to a incandescent light bulb during a year. So yes, there is consumption, but it's very low. We've also worked very hard on what I sometimes call the parasite consumption of electronics. So standby mode, for example, consumption has considerably gone down for the control systems as well, also recently.
Thanks, Anders. We've almost hit 1 o'clock, so I'm just going to ask you one final question before we wrap up. When you say that the solar shading should be considered at the concept stage of the project, who do you recommend to take the lead on this, and how is it best to manage the process?
In general, I would say it's the architects and the M&Es together with the sustainability consultants. It's within that group. To my experience, very often in projects that I've been involved with in the past, the architect will handle let's say, the global concept of the building, and it's the HVAC equipment is more or less subcontracted to the HVAC consultant. But I think it's the combination between the two. I think the understanding of the dynamic, the contribution of shading is probably easier to reach amongst the M&Es and sustainability consultants. So those of you working with that, you can then create the data and information, helping to bring it to the architect, so the architect can feel reassured that by doing these maybe new things, it's nothing dangerous or something. We all fear change and to try new things. So I hope that answers your question.
Perfect. Thanks so much, Anders, and thank you very much for your time today. It looks like you covered a lot of great content, and we had some really good questions coming through. Just so everyone knows, we have recorded this webinar, and we'll be sending out a link for it tomorrow, as well as a feedback survey if you can give us your insights. And Anders is also happy for us to share his slides. We'll pop them in a PDF for you, and we'll send them out as well. So thanks very much again to everyone. And just before we go, one final plug for Green Cities. So it's coming up next Tuesday. Well, starting next Tuesday, we've got the warm-up day with the masterclass and site tours, and conference beginning on the Wednesday. So if you haven't got your tickets, jump online and book them in. After that, and that's all we've got time for today. And thank you very much for everybody who tuned in.